here's one more example to take a look at about how to find an inverse and then find the domain of the original and the inverse function. So like in our last video, we'll begin by switching x and y. So my first step will be to write x equals 2 times the sine of y minus 1. So this one will be a little bit different, of course, but the same basic steps, or we'll follow the same basic steps. So to start getting y by itself now, I'll begin by adding 1 to both sides. So x plus 1 is then equal to 2 times the sine of y. Next, I guess I'll divide by 2, and I'll just divide that whole side by 2. So x plus 1 over 2 is equal to the sine of y. And finally, to finish getting y by itself, I'll need to get rid of that sine. Well, hopefully not surprisingly, to get rid of a sine, we'll do an inverse sine. So I'm going to do inverse sine, the sign with a little -1 symbol there, and I'll do the inverse sine on the other side. Sine and inverse sine are inverses, of course, so they'll cancel out, which leaves me just with this function, the inverse sine of, I'm going to use parentheses, excuse me, the inverse sine of x plus 1 over 2. That's my inverse function, and remember, functions, equations need equal signs, so I'll put equals. Y would be fine, or if you want to be really fancy, we'll do the inverse function, f with a little -1 symbol. So there is the inverse function of what I started with. My last step of this problem, though, is actually to find domains. I want to find two domains. One is going to be the domain of the original function, which, again, if you watch the last video, that's really easy. Since the regular sine wave goes forever left and right, my inverse is, or my domain is just -infinity to +infinity. I can plug any value I want in for x. To find the domain of the inverse function, though, it's a little bit trickier if you don't remember that all we're going to do is find the range of the original. So I'm not even going to mess with the inverse function. I'm just going to find the range of this original function, because remember, with inverses, the range of the original is the same exact thing as the domain of the inverse, because we just switch things around. So to figure out how high and how low that graph goes, I'm going to think about sketching a graph of what it would look like. I don't actually need to graph it, but I'll think about what the graph would look like. So if I were graphing this sine wave, I see that I do have a midline shift. My graph has been moved down one space, so there's my midline. And then from there, the amplitude of my graph is 2, so I would count down 2, which would put me to a low point of -3, and I'd count up 2, which would put me to a maximum of 1, which means my range, or the domain of the inverse, is going to stretch from -3 at the low end to +1 at the high end, and I'll use square brackets because I can actually get to those locations. So there's sort of a visual way to do it. I also gave out this formula in class if you don't want to graph it, but want to think sort of with formulas, I suppose. The formula is simply find the midline of your graph, and then add or subtract the amplitude to it. That'll tell you how high and how low the graph goes. Well, for the original, which would then get you the domain. So in this case, my midline was -1, my amplitude was 2. So if I solve this, -1 minus 2 gets me the -3, -1 plus 2 gets me the 1. Either way you want to think about it, there is our domain of the inverse, the domain of the original, and our inverse function.